Swayam Prabha. Digital India. Educated India.
Hello students. As part of understanding decarbonization in buildings, in the last class we saw some of the renewable building materials as well as their characteristics, and we found that renewable building materials are in no way inferior to conventional building materials when it comes to either their strength when used in appropriate places and for appropriate uses, acoustics, thermal performance, and ability to withstand moisture. Today we will have a look at some of the renewable building materials and the technologies which we can use for those building materials, giving us an overall low embodied buildings with low embodied carbon. So today we will have a look at some of the building materials, part 2, the properties of these renewable materials, some examples of these. So renewable materials are derived from natural sources and can be replenished over time. These materials are those which can be manufactured or generated quickly enough to keep pace with how fast they are used up. They can be made from natural products or synthetically produced, and they often include recycled products. By utilizing renewable materials, we reduce our dependence on non-renewable resources such as fossil fuels and minerals. Renewable materials are plant derivatives or agro-based and thus can be regenerated over again after the initial crop has been harvested. Though not all renewable materials are plant-based and agro-based, because some of the materials could be like earth, clay, lime. A renewable material must not be consumed more quickly than it can regenerate. With the help of technology, construction companies are utilizing waste materials with recycled commodities such as mining waste, glass waste, burnt clay to develop renewable materials for construction. The output is a low maintenance and long lasting renewable material for construction. Manufacturers are designing these materials while keeping in mind the entire construction life cycle composed of structural design, parameters, production techniques, and maintenance methodologies. Regenerative plants like bamboo are a good example of renewable building materials as we saw in the last class. Rapid regenerative properties along with low cost make it a favorite for manufacturers in the market. Sugarcane is another example. Sometimes banana fibers also is a good example of naturally grown regenerative raw material which can be used to create bagasse, which is a renewable material used in construction. Besides being composted in a short period without causing environmental harm, bagasse is used as a biofuel for producing energy and heat along with electricity. These multifaceted benefits pile up its demand in the market. Now we will again go through some of the properties of renewable building materials. Renewable materials are natural. Most of them are agro-based. So, they are agro-based most of the times, natural, found in abundance. They are replenishable. So, they are self-generating in a way. For example, bamboo. They are indigenous. So, they have local adaptation because they are indigenous. They are lightweight because they are mostly made up of dry agro based, and they have low embodied energy because they are natural. They are fit for on-site and off-site construction. They have low carbon emissions because they are natural, and they have carbon sequestration again because they are natural products. So, carbon sequestration has given natural renewable materials an edge over synthetic materials as they can be seen as carbon negative. The overall environmental burden is reduced by the fact that plant-based materials have locked up carbon when growing, which synthetic materials can never do. Studied in the embodied energy consumption in buildings which have been carried out by UNCHS in the year 1991 have indicated that a high proportion of the energy used, almost up to 90%, is used in the production and transportation of building materials before they are brought to site. Only 10 to 20% of the energy use takes place in the on-site construction process. Thus, renewable materials which are natural have less embodied energy. So, carbon sequestration, which is a very important part of any renewable material, has given natural renewable material an edge over synthetic materials as they can be seen as carbon negative. Hence, agro-based renewable building materials need a lot more research to be done in order to be brought into mainstream building industry. In our case, we will also consider mud as a renewable building material since it is a natural material and there is no dearth of mud. If you look at the characteristics and properties of renewable material, mud follows almost all of these except for being, say, lightweight or self-generating. Except for that, it abides by most of the characteristics of renewable building material. Now, encouraging adoption of renewable material is a very key component in decarbonizing buildings. Recent government regulations encourage adoption of renewable materials. In the mission to transform the construction industry into a sustainable sector, various renewable materials in the construction market have been identified, which hold the potential to replace the existing construction materials. The major objective here is to save energy, water and various non-renewable resources to gain and reap long-term benefits. In order to propel such initiatives leading to sustainability, Recognized organizations such as LEED are encouraging the construction companies by avoiding green building certification. Also, the CII, Confederation of Indian Industry, awards green certification to the products itself through Green Pro as an organization. The growing trend of such recognition has been increasing the supply of renewable materials in construction industry. Let us now look at few of the materials and the construction technology which makes the combination of building material used with that particular technology to give rise to low carbon buildings. Let us look at burnt bricks. Now, if you look at burnt brick masonry, for the per meter cube, burnt brick masonry has 2 to 3.4 gigajoules of embodied energy. Whereas, if you look at composite blocks, it has half or less than half of the embodied energy which a burnt brick masonry possesses, because it has 1 to 1.35. Burnt brick is manufactured by casting mud blocks and firing it in kilns. The process of firing the burnt brick in kilns using certain type of fuels. Sometimes the fuel is just, the mode is just straw, hay. It could be anything. Sometimes it is coal. It could be any of those, and that is what increases or decreases the embodied energy in burnt bricks. If we look at the embodied energy of stabilized mud block, it is almost 1/4 of that of burnt brick. The stabilized mud blocks are nothing but masonry, and these are burnt bricks are basically manufactured by burning the bricks at high temperature. So, you process the clay, and the clay minerals, the minerals that are found in the clay, they undergo irreversible changes which gives strength to the brick. But in this process, it uses high energy. Here, conservation of energy as well as clay mineral resource become important from environmental and environmental angle, where when it goes back to the soil, will we be able to retrieve the minerals, becomes a question mark. But SMB, stabilized mud block, they are energy efficient, eco-friendly alternatives to burnt clay bricks. These are solid blocks which are manufactured by compacting a mixture of soil, sand and some stabilizer. Normally that stabilizer is cement or lime. If it is lime, it becomes even more environmental friendly, with of course a mixture of water. After 28 days curing, these blocks are used for wall construction. So, this becomes a combination of mud plus stabilizers, which are mostly cement and lime. Whereas, if we look at fly ash blocks are a mixture of lime plus fly ash along with a crusher. crusher dust. This is compacted into high density block. Now, lime reacts with fly ash and the minerals in the fly ash, forming a water insoluble bond, and that gives strength to the block. So, if the embodied energy of brick masonry is 2 to 3 gigajoules per meter cube, stabilized mud block is 0.5 and fly ash is 1 approximately. So, you can imagine how much reduction in embodied energy can take place by using renewable material or composite renewable material. Now we will look at